right? And you want to consume it, and you consume it, right? The capital stock can be, this is a good that can be either consumed or used productively. And so consumption also includes 1 minus delta Ks. It's like you have a machine and you decide to eat it. It's kind of odd, but that's the way it is. Now we plug this in here, right? And so you can write down the optimization problem as ut equals sum from t equals to infinity, u, and then fat bracket ASF KSL plus 1 plus R BS minus GS minus KS plus 1 minus delta Ks minus BS plus 1. Good. That's exactly what you have on the slide. Now, what's next? Well, let's write this down for using the summation. You know, the summation sign is a very practical thing because, I mean, writing this down as a sum would be impossible because it goes into the infinite future. But now I'm doing it anyway. Don't worry, I'm not going into the infinite future because I want to go to Ho Chi Minh City in the afternoon and you want to take a weekend. This is U ATF KTL plus 1 plus R BT minus GT minus KT plus 1 minus delta KT minus BT plus 1 plus beta U AT plus 1 F KT plus 1L plus 1 plus R BT plus 1 minus GT plus 1 minus KT plus 2 plus 1 minus delta KT plus 1 minus BT plus 2 plus ... That's sufficient. So give you a minute to copy that. And just indicating that this is, of course, CT, and this is, of course, CT plus 1. Now, Min, you don't know that yet, but I've trained the audience to give an answer to a specific question. So what do economists do when they have nothing else to do? They take derivatives. Okay, so I'm joking, but we do take derivatives all the time because we want to find optima. Now, when we take a derivative, we have to know with respect to which variable to take a derivative, and that's the big question I would like to ask the audience. Now, we're maximizing this. Now, how do we maximize this? What do we choose optimally? Yeah, but consumption has been replaced. That's the beauty, that's the bright side and the dark side of choosing this approach. We're replacing, yeah, what? I'm collecting suggestions. look at this. Now let's go by exclusion. Can you choose AT? No. Can you choose KT? KT you cannot choose because it's the state variable, right? It's the variable that you find when you're in purity. So can you choose BT? No. Can you choose GT? No, that's what the government. Can you choose KT plus 1? Yes. Yes. So we have a first one, right? We have a first candidate, right? Can you choose KT? No. Can you choose BT plus 1? Yes. Okay. Okay. So what we essentially, we transform a problem where you choose consumption into a problem where you choose the optimal value of the next period state variable. Implicitly, of course, this also gives you consumption, right? Because once you've chosen KT plus 1 and BT plus 1, that implicitly defines consumption. Now let me replace that blue cloud. I mean, the cloud came to my mind just a second ago, so let me replace the blue cloud by a red cloud. Now, where is KT plus 1? KT plus 1 is here. Where is KT plus 1 in that thing? In the production function, right? So you have KT plus 1 here, and you have it here. And where is BT plus 1? BT plus 1 is there. Okay, and now we're ready to do the optimization, right? So we take a derivative with respect to BT plus 1, which is U prime at CT times minus 1 plus beta U prime CT plus 1 times 1 plus R equals 0. Where does the minus come from? The minus comes from here. Where does the 1 plus R come from? It comes from there. So you get U prime CT equals beta 1 plus R U prime CT plus 1. Now, this fellow should be familiar. It is the good old intertemporal Euler equation. That's something that we derived already yesterday when when output was exogenous. Now, the second thing is dUT over dKT plus 1 is U prime CT times minus 1 plus beta U prime CT plus 1, and then you open the bracket and you have AT plus 1 FK, KT plus 1 L plus 1 minus delta. And that should be equal to 0. And if you transform that, then you get U prime CT equals beta AT plus 1 FK KT plus 1 L plus 1 minus delta U prime CT plus 1. So these are the two first order conditions, and you have them on the slide, and you have them. What I did is I derived that for the optimal capital stock in T plus 1 and the optimal net international investment position in T plus 1. But be aware that the representative consumer does not just look at the next period. It also looks at T plus 2, at T plus 3, at T plus 4. So this is like an infinite number of first order conditions, but they look all the same. So let me give you some time to copy that, because I'm good. So we have two first order conditions. And now if you stare at that for a couple of minutes, then you realize that these first order conditions look oddly similar. And in fact, this will move us to the next thing. Right? So we have this U prime CT is the same here, right? And the beta is the same here. And you have the U prime CT plus 1 is the same here. So that implies that, of course, what we have in squared brackets has to be equal to 1 plus r. Otherwise, it doesn't make sense. Now, so let me bend my knees and say, okay,